seats, otherwise we'll have lunch at 3. So to cut short that, let's start the session. May I request those who are having a tea, please bring your tea to the table. You can have it at the table. "6G building metaverse ready mobile network." That is the theme of the session. बंद कराओ ना. Ladies and gentlemen, please let's start the session. Please join us. Please join us. Please join us. "6G building metaverse ready mobile network." The session is going to be chaired by Shri A. Robert Ravi, who is the ITS officer, who is now currently at Chief Technology Officer, Government of Tamil Nadu. May I request Shri Robert Ravi to come on the dais, sir. In this session, we have Alka Asthana, who is the ED of TCIL. May I request Alka to come. She is a former ITS, now with TCIL. I request Navneet Kataria, Product Marketing Manager of Enritsu. Oh, he's online. Okay, he will be online. Okay. Narang Kishore, the young man of the industry, please come on stage. And the Cyberman, Colonel Inderjeet Singh. So we have a fantastic panel today. Sir, not wasting much of your time, over to you.
Good afternoon, ladies and gentlemen. I think welcome to this panel discussion. This panel is going to be a discussion. The topic is going to be a very, very interesting topic. How are you going to build metaverse-ready networks? As we were discussing yesterday and today, you know, the main movement towards 6G is going to be an immersive world. We're going to have a combination of the virtual and the reality combined together. So are the networks ready? Some of the key takes: one, we know the network, as we mentioned, two key essential parameters. Your bandwidth should be at least 1 terabits per second. And you should be able to take latency of less than microseconds. So your network should be ready for that. That's the key thing. The other one, once we start doing talking about latency, it is more essential that the edge computing moves towards the edge. So your mobile network should be ready to ensure that the edge computing is also taken care to a large extent. And a new concept of the small data analytics is coming up in a big way. We have heard about big data analytics all along. Now, big data analytics gathers data from different at a centralized place, and the analysis happens. As 6G, as we know that because of the federated learning, and things are moved to the edge. So the small data analytics requires a lot of processing power. This also should be inbuilt in the network. So your network should be able to take care of these essential capabilities. Once we talk about data processing, obviously we have the AI and ML, FL all come in together into this network. And the most important, last important thing is your security. And the network should be security. So of course, blockchain will be a part of it. So how are we going to bring in these key elements of say blockchain or AI, FL, ML, and your edge computing into your mobile networks? So that is going to be a real challenge. Mobile ready. This panel, I'm very sure we have eminent speakers ranging from different walks of life, and they are specialized on their own. I'm very sure they'll enlighten us how these mobile networks are going to be ready for the future ready, especially in the metaverse environment. Totally. Especially, I think you have that already a telecom infra project is on across the world, and I think we are glad at least two of our own TSPs, the Airtel and the Vodafone, are also a member of this telecom infra project, which actually is into developing this metaverse ready mobile networks. So without making much time, let us hear from what our eminent speakers are. Our first speaker for the day is going to be from Navneet Kataria from Andritsu. So he is going to talk about more on this, how this metaverse ready mobile networks are going to be there and what is going to be the challenges, solutions, and how 6G is really going to take on. On to you, Mr. Navneet. I think he's joining on online, I believe.
Yes, I'm here. If you guys can hear me. Hello, everyone. Can you guys hear me? All right. Am I audible?
Yeah, you're audible. Please go ahead, Navneet.
All right. Thank you. Thank you so much for giving Andritsu this opportunity. Respected the panelists and everybody who is a part of organizing this 6G initiative in India. And without taking a lot of time, what I'll do is I'll start sharing my slide set. And I was really influenced by some of the statements that the eminent panelist just mentioned about how networks are going to play a very important role. In fact, what we are hearing more and more about 6G is there would be human to avatar, avatar to avatar, digital twins will exist, and you could be in India, but you could be virtually taking classes somewhere in Belgium with the help of some smart glasses. But as the panelists mentioned, the frequencies will matter a lot. And the higher you go into the frequencies, the more modulation bandwidth is available by which you can actually reach to those 1 terabyte of speeds. Apart from that, there's a lot of talk already going on about NTN, which is the non-terrestrial networks, and you might most probably see by the end of this year or maybe early next year, you will have 5G eNode Bs, the base stations somewhere in space on a satellite payload, and you would be able to enjoy the 5G networks while you are traveling. So without further ado, what I'll do is I'll start sharing my presentation. I've tried to keep it as small as possible. I'll try to be as quick as possible as well. Let me just quickly share my slide with you. All right, can you guys see my slide? Is it okay?
Yes, but slightly, yeah, please go ahead.
All right, thank you. So the agenda, I'm going to keep it short. As I said, I will walk you through about what 2G, 3G, 4G, 5G, and what 6G is bringing on the table as far as the technology is concerned, and why is it so important. I mean, those were the eras in the late 1990s that we were thinking about, hey, 2G, GSM, and now we are in 2023 and we are thinking about, okay, can I stream HD videos? Then I'll basically touch on what frequencies are being considered for commercial 6G deployment, and there are some other applications. Just like 5G, like we had FR1 and FR2, even for 6G, there are a couple of bands in the lower frequency range and a couple of bands in the higher frequency range for higher data rates and higher modulation bandwidth that we could enjoy. And then I'll talk a little about practical challenges for beyond 5G. Some countries are calling the early 6G as beyond 5G. So I'll be covering onto that. And then I'll most probably during the entire presentation, I'll be covering as to how Andritsu solutions are helping our researchers and the research community to actually excel in the 6G world. So quickly going on to the evolution, technology has surely taken a big leap. As we all know, 2G, there was voice services and data at the rate of few kilobits, and then we moved into the 3G and 4G world where it came with a lot of promise of data rates up to 1 gigabit per second. And then all of a sudden, we made a real big jump by 5G, and the data rates were going up to 10 gigabits per second. And that is where all this, EMBB, ultra reliable low latency communication networks, massive machine type communication, even artificial intelligence up to a certain extent was being discussed at the very end of 5G, because we were able to enjoy those kind of data rates. Now 6G is as the panelists said, gonna support data rates up to 1 terabits per second. And this on the right-hand side, my friends, will be a reality. You will be able to talk to your dear ones and the loved ones by small devices that could holographically display your entire body in front of your loved ones. And to do this, you know, you need data rates which are very, very low in latency, and that is what 6G promises. So you could have devices that will be supporting on the go while you're traveling and you're doing your stuff. But there would be devices that will be supported in the higher frequency ranges, especially as I will speak in the next slide, in the D and the G band, where the modulation bandwidth is so huge that you could transmit terabits of data into few milliseconds actually. So some of the terms that are being commonly used nowadays as we talk more and more about 6G is digital twin world, holographic calls, touch screens will actually go obsolete. You will be able to swipe your fingers at a distance from your electronic devices, and just by gesturing you would be able to make calls, you know, download the beautiful videos, high definition videos. Apart from that, as I said, the non-terrestrial networks are being discussed a lot in the initial phases of 6G, wherein you will have a base station somewhere in a satellite payload. And it doesn't matter whether you are in the middle of a forest or somewhere, you will get high data rates. And that is what Mr. Elon Musk from SpaceX is trying to do. He's trying to put 5G payloads, a 5G base station in the payloads of the LEO satellite network that he's planning to do. So again, it only is not related to mobile networks. There are a lot of other applications that will benefit from 6G. And when I say imaging, you would have very high resolution sensors that could image every nanoparticle. And again, for transferring data of that magnitude, you need a lot of bandwidth. So imaging, sensing, ultra precision, gas detection, these are some of the new applications being talked about. Of course, as we talked about metaverse, human to avatar, avatar to avatar, and you know, the virtual world will exist. Extended reality, of course, that's one of the main topics being talked about as well. So all you need is a pair of really smart eyeglasses, and again, as I said, you would be sitting somewhere in India, but you could take your classes or talk to your loved ones or visit places actually and see, you know, how different monuments were built. So just a quick one on how did we reach here, you know. I think we were able to make use of the spectrum that was available to us at various times, and depending upon whatever hardware we could build at that time, we were able to make use of that technology. Now, the problem with lower frequencies is that there is lesser of modulation bandwidth available. That means there is a limit to data that you can send on these carrier frequencies at the lower frequencies. Moving into the higher frequencies, of course, it has a lot of advantages, and that's where I'm focusing. Moving into the higher frequencies, which are being talked right now, like the millimeter wave, there is a lot of wider modulation bandwidth available, and that definitely translates to higher data rates. And there are several other advantages to that as well, because as you go higher the frequencies, the size of the antennas or the devices actually can go really, really small. So that means for supporting higher data rates, you need smaller devices, which actually is a blessing in disguise, because you could have body sensors gathering all sort of data, and it would be talking to the base station, sending your data to the hospitals, you know, and all that stuff. So smaller size definitely is there, but then it has some problems to it as well. The smaller the size is, the less directive your antenna would be. But then we are all engineers. We have made some progress as to how can we make use of the technology. So instead of only one antenna, we are able to mount several of thousands of antennas onto these small chips. And that gives us a laser beamed antenna, which is highly directive and can be used for, again, several applications. So massive MIMO, beamforming, we're all talking about different technologies that are supporting higher data rates and smaller sites. So some of the advantages of moving in higher frequencies, as I said, more spectrum, more modulation bandwidth, efficiency is enhanced because these are very small devices. So they are actually very less power hungry devices. So there is a reduction in power consumption as well. Size is smaller. And then, as I said, to overcome the limited gain of a single antenna, we were using technologies like MIMO and beamforming. So then now quickly moving the focus onto what are the frequencies being considered right now for commercial 6G or just 6G deployment. So there are a number of candidates in the 7 gigahertz to 24 gigahertz range for supporting on-the-go kind of applications. Just like we had in 5G, we had FR1 and FR2. So it looks like the lower frequency range for the 6G networks would be somewhere in the range of 7 gigahertz to 24 gigahertz. However, it's not all rosy when it comes to higher frequencies. There are a lot of challenges, like the basic or the simplest challenge that everybody is suffering right now is, as you go higher the frequencies, the over-the-air losses are too much, and how do we compensate for that? And then a lot of material measurements and material characterization is also very important, because imagine you land up making a 6G base station and you cover the base station with a material that is posing a lot of attenuation to those higher frequency signals. That becomes a problem. So again, we are all engineers. We came out with, okay, we have a problem, let's find the solution. Okay, so what we did was like low-cost base stations with beamforming and higher modulation techniques. There's a concept getting very famous nowadays for 6G and even for beyond 5G, which is called as the RIS. It's the short form of reconfigurable intelligent surfaces, and I'll cover a little bit about this in my next couple of slides. And then, of course, a lot of research being conducted right now in material measurements, where Anritsu solutions are being, used widely and by some of the top-notch research institute across the globe. The second band, which is being considered for 6G, is the higher frequencies, not only for front haul and back haul, but for sensing, imaging, other devices. And those two frequency bands that are being researched the most is the D band, which is from 110 to 170 gigahertz. And then we have the G band, which is 140 to 220 gigahertz. So a lot of research going there. There, the challenges in comparison to the mobile world is a little different because these devices are so small again. Imagine if you have to make an amplifier in D band and G band on a chip or on a wafer. So you need to characterize those devices. And those devices, I'm just taking a vague example of an amplifier. All these devices, be it an amplifier or a filter, they are made up of some fundamental components like transistors, and all those transistors needs to be precisely and accurately characterized for the responses, not only those at those higher frequencies, but starting from a very low frequency right up to those broadband frequency ranges right up to 220 gigahertz. So that's a big challenge. So the solution is, there are some eminent current solutions available in the market today, but then as the technology is going forward, we need to support the market with newer and newer and improved solutions. So these are some of the challenges and solutions that we are talking right now for 6G world. Let's dig a little bit deeper into the lower frequency challenges and the solutions. So as I said, the 7 to 24 or 28 gigahertz will be some of the candidates being considered for 6G. So the basic problem there is signal propagation. And the biggest research area right now is actually focused on two things. First thing is channel sounding. Now, this is a technical term, but in very simple language, what we're trying to do by channel sounding is we're trying to see how the 6G higher frequency signals are going to travel from one place to the other, say in an open area. Okay, because we want to characterize the channel and say, okay, these are going to be the losses, these are going to be the challenges for these higher frequency signals. And the other one, as I said before, is the reflective intelligent surfaces. Now, today how it works is if you want to cover, say, 2-kilometer radius for a 5G network, you may have to deploy, say, maximum 1 or maybe 2 base stations, right? Because the frequencies are lower, so they can travel farther more. However, when we talk about 6G, because the frequencies are so high, what will happen is there are 2 solutions. Number one is either you provide limited coverage to your customers, or you land up installing number of 6G base stations. And that commercially and infrastructure-wise doesn't make a lot of sense. So the problem is if you go ahead and invest a lot of money in making these 6G base stations at like say 500 meters apart, that's a lot of money. But if you don't do that, then you cannot provide coverage to your customers. And that is where the reflective intelligence or the reconfigurable intelligence surfaces comes into action. So I'm depicting an example here. Consider this as a 6G base station. If there is a customer who is in direct line of sight and very close to this 6G base station, all right, he's going to enjoy a lot of high data rates, maybe 1 terabits or 500 Mbps for sure. However, say suppose there is a customer who's just behind a building, right? Now the over-the-air losses and the attenuation of those higher 6G frequency bands is so high that this poor customer, no matter how much he's paying for the 6G services, he will never get a signal. So then there will be a lot of complaints. So there are 2 solutions, as I said. Either you install another 6G base station, which is very close to this customer, or the alternate is installing a reflective intelligence surface. And these reflective intelligence surfaces are nothing but a piece of kind of a transparent paper that you could actually put onto a wall or a window. And what it'll do is it'll reflect the 6G signal at the area where there were no 6G coverage. So a lot of research right now, and a lot of research I think in India also is going on. But what we have seen, at least so far, a lot of research right now in Europe is happening on this topic, and we are very closely associated with some of the bigger research areas there. So now, if you install this, and these are transparent to the eye kind of services, you know, it could be passive, it could be active. And depending upon the structure of the RIS, you would be able to steer the beam in any direction that you want. So that's the advantage. So for these 2, which is number one, the channel sounding and the reflective intelligence or the reconfigurable intelligence surface testing is concerned, Anritsu has a very unique solution, which is the distributed 2-port VNA. So I'm sure everybody here has heard what a VNA is. It's a vector network analyzer, but normally a VNA has 2 ports embedded in the same box, right? So for making long distance measurements, say suppose you have a RIS and you want to see how the angle of these high frequency signal is behaving, you have to have very long cables, and that creates a lot of problems. Now, up till today, the frequencies of the signal was very low, so the phase characteristics being tested was not that important because you could measure the phase pretty accurately. However, with the 6G signals, because the wavelength of the frequency is so small, of the signal is so small, the slightest of the phase variation will cause havoc into the network. So what you need is, you still need a VNA, but the best way to characterize for at least these 2 applications is if the VNA could be, the ports of the VNA could be extended beyond the traditional 2 meter or 5 meter. And that is what Anritsu has come up with a solution. So this solution is a 2-port VNA fully reversing, and then it can do full vector-corrected S parameter measurement. It's very ideal for reconfigurable intelligent service testing, channel sounding, and antenna measurements in anechoic chamber, or even for the lower frequencies. So that's one. Now quickly shifting my focus, because I know I'm running short on time. I just have 15 minutes. Quickly focusing out from the lower frequency, I want to jump to the higher frequency, because that, I believe, is more of a fundamental problem or fundamental research that a lot of people are trying to cover right now. So in the higher frequency, as I said, these components or these chips or these devices are actually on wafer. And it could be, as I said, a diode or a FET, it could be a MOSFET, different devices. But they need to be characterized from a very low frequency, say of the order of a few megahertz, but right up to the D band or the G band. So you need to have an instrument that could actually cover in a single sweep from few megahertz to say 220 gigahertz or 140 gigahertz or 170 gigahertz. Now, the problem, at least till today, there are some solutions, but not a lot of solutions available. So say suppose this is your device on a wafer and you have a traditional 2-port VNA. The way or the solutions available today is you can only make these measurements in a banded fashion. So what do I mean by that? The solutions today cannot provide you with the broadest or broadband frequency coverage. So starting with, say, 50 megahertz or going up to 110 gigahertz. There are no solutions that can do it. So what the researchers are forced to do, because they don't have a solution like that, is they make the measurements in chunks. So they start with few megahertz, goes to say 70 gigahertz. Then from 70, they go to 110 gigahertz. Then from 110
Navneet, you need to slightly start winding it up.
Yes. I'm just one more slide after this, and I'll be done. So the practical problem here is that you have to keep moving your millimeter wave modules. You have to make measurements in chunks. But what that leads to is a disconnected or a discontinuous measurement, which is not that good for the research. However, as I mentioned, Anritsu has come up with a solution which can give you a broadband frequency coverage right up to 220 gigahertz. You don't need to do calibrations, and you can do one-shot broadband device characterization in one go. So that's the advantage. Now, once you have these characteristics for your fundamental components, you could design anything that you want. So that is what this slide is telling you. And I'm just trying to give you some more examples. I'm almost done here. But the way the measurements are done today, they are very time consuming and they are costly and error prone as well, because you have to do multiple connections and multiple time calibrations, which leads to a lot of problems in the calibration stability and on the measurement accuracies as well. So moving on, this is my last slide. There's another area which is being discussed a lot, and that is, AIP or antenna in package measurement, because up till today, you could have an antenna attached to your module and you could design things accordingly. But as you're going higher, the frequency, everything is on a chip and you have an antenna embedded there. So you can't separate the antenna. So how will you measure it? So you have to measure it as a system. This slide is telling you what Anritsu has. And again, I just wanted to emphasize we are associated with a lot of high-end research organizations across the world. We have few customers in India as well. But this is a VNA, a broadband test set. We have our own millimeter wave modules, and then these are the probes that can sweep from 70 kilohertz right up to 220 gigahertz. And my last slide is AIP, as I said. So on the right-hand side, you could see that there is a wafer, and then you have the antenna, which is embedded in package or on the chip, and it starts to radiate. Now you have to characterize these things, and it's not trivial. So Anritsu has been helping a lot of customers to make these antenna in package measurements, again at very, very high frequencies, ranging from 70 kilohertz right up to 220 gigahertz. With that, I'll come to a stop. I think I took more than 15 minutes, but these are very interesting topics. And we'll be open to collaborate with you people as well. These are my contact details in case you need help on the instrumentation side or anything on the technology. We'll be more than happy to help. Thank you so much.
Thank you, Navneet. That was real thought-provoking and very interesting, forward-looking presentation of what are the challenges we look forward when we start developing 6G networks. Now on to the next speaker. I welcome Alka, who's again having years of experience, a lot of work done in 3G, GSM, etc. And also in ITS, also now working as ED in TCIL. On to you, Alka.
Thank you, sir. A real privilege to be sitting alongside you and others. And it's really exciting to be talking about 6G now. I don't want to, share my sense of deja vu with you because, then you will feel we are going back in time. But yes, we had started talking about 5G a few years back. Separate, space and resources for the disaster workers to kind of respond quickly. These are situations which are extremely, important to be thought through and then solutions to be provided. When we are working with the labs, with the educational institutions, covering various use cases, their perspective, the educational institutions' perspective is of course to see what the students can learn out of that entire network, out of the use case devices. But the rest of the world is watching them to see what is it that the students and the faculty will come out with so that these could be adopted in the real world and for real life situations. So all this thought process should come together where, right now with 5G, we are able to develop it, and with 6G, it really becomes next level. I was very interested in the entire concept of tactile internet, which is coming with 6G. I work a lot with people with disabilities, and there is, it's a fair amount of shock and surprise to note that there are still websites and applications which are not accessible to, let's say, blind people. There are talks and classes, smart classes, which are not accessible to those who are deaf. There are situations where people who are mute or who cannot speak can't communicate, despite the fact that communication has reached to another generation, right? 5G, and now we are talking about 6G. So tactile internet, to me, talks of people doing things on gestures, doing things without limbs, doing things without all the faculties being available, and being made included part of the society in general. So that's what technology can deliver. And I hope we all work towards real, solutions to these, I wouldn't call them problems, but these are situations which can be resolved using technology. So I really encourage or urge all of you to, come out with solutions and ideas for this phase of our growth. India has made 6G as a target to be achieved by 2030. We have study groups, which are working in various aspects of 6G. Government has come out with the paper, and it's a beautifully written and put together document. All of us, if you haven't read it, please read it. The position paper, it's extremely informative and also very forward-looking. I am very excited to be part of this growth, from this generation to the next. I am yet to become very subtle in the 5G era, but I'm looking forward definitely to also be part of 6G and contribute therein. Thanks a lot, and I'm trying to cover up for the time taken by Navneet.
Thank you, Alka. Just before we go to the next speaker, quick question. What are your thoughts on what TCL is going to place itself in the 6G era and roadmap in terms of forming groups? And also, especially with the CNPN network being pushed in a big way, which is going to actually be one of the main drivers of 6G. What are your thoughts on this?
So we've already started working on establishing CNPNs with various, let's say, user groups. It's not about, we have signed MOU, for example, with BSNL, where we can use their frequencies for the CNPN. Government has also given that kind of a mandate to say that, take it forward. Now, 100 5G use case labs that we are talking about and that are getting set up are also giving this, this roadmap for other ministries and users and organizations to kind of pick up from there. So we were just recently having a conversation with, as I said, Ministry of Coal, Steel Ministry, for instance. We signed an MOU with Bokaro Steel Plant for converting their unit as a completely communication and a digital platform oriented location, and all of this would definitely require a very holistic kind of an arrangement where communication platforms also become part of the overall structure, and it also involves the cyber security, it involves physical security for these perimeters. All this is kind of being brought together. We play the role of, for want of a better word, integrator of sorts, a master system integrator, if you may please, but it's also to trigger that entire thought process of what can be done, what should be done, and how it is to be done.
Thank you. Okay. I think next speaker, now when we talk about 6G, as we know that number of devices is going to increase, mobility is going to increase, of course. One of the key things that is always talked about is sustainability. Of course, the government, even 10 years before, we started working on the green telecom, and then we brought out guidelines on green telecom. Of course, it's an evolving process, and as we were even discussing yesterday, we are into even energy harvesting technologies where the devices could also be practically moving towards a battery-free environment, the sensors, the IoT sensors, etc. In this sphere, we have Mr. Kishore Narang from the Narex Techno Lab. He requires no much introduction. One of the very important person who was associated with a number of reference standards, especially in smart cities, smart metering, etc. On to you, Narang.
Okay, good afternoon. So I'm going to give you a shock. I'm going to take 1 hour tutorial on this topic. Okay, just kidding. Just kidding. Though the topic does deserve that kind of a time, but since we do not have, what I've done is I have an elaborate slide deck. I'll be skimming through it, stopping at a very few slides. But I'll be sharing it with the organizers. You can go through it at leisure, and then we can have side discussion, one-to-one, or during the lunch, or later on, maybe one-to-one drinks or whatever. So I think, so what is the context? Why we are talking about this sustainability, and how do we look at sustainability? As an ethical imperative, as a standardization imperative, or how all? So we already know that emergence of these disruptive digital technologies has already begun, profoundly reshaping our lives, our interactions, our lived environment, and as adoption of these technologies becomes widespread, they are likely to play a substantial role in society's energy consumption and environmental impact. And we have already been seeing that this discussion in COP26 and 27, all this climate change, and everybody talking about climate change is a big topic of discussion. And there's a whole lot of discussion, deliberation. We have started getting claims on net zero by this, every MNCs, global organizations, countries are making promises that we will go net zero. Is it joke? Are they joking? I think we need to, it's not funny. All these things are at a very superficial level. To be being a skeptic and candid, because I'm a hardcore technology person. I've been designing all these systems for last 45 plus years. I understand technology. I'm a technology evangelist also, but an innovation evangelist. But then it's high time we also started understanding the other aspects. Is this the evolution we expected? Absolutely no. Today, we are living in a very small world, an increasingly hot, crowded, and contentious one. The combined effect of climate change and society's impact on Earth is intensified struggle over the natural resources while also threatening our infrastructure, food system, and quality of life. Today, nature no longer runs Earth. We do. So it is up to us what kind of future we design. Climate is not politically strong enough to fight carbon by themselves. It needs us. And that's where the question that a lot of people are asking today, what will the future of life on Earth, and that too particularly of mankind? And it has been observed that in last couple of centuries, the technologies we have developed, we have been working on, have had major impact on the Earth's climate and nature's equilibrium. Some even believe that we are at point of no return. However, while technology has created these problems and responsible for most of all these problems, it also has solutions for it. But do we really strategically look at it? How do we do that? It's increasingly clear that today's environmental conditions are not sustainable, and we have done a lot of innovation in different areas. It is now time to work on this particular domain to see how we can leverage our learnings, our technologies to address the problem of global warming and consequence on human this thing. And in last couple of years, particularly during pandemic, these two diametrically opposite paradigms came to the forefront on the same table for discussion. Digitalization, we saw how it came to the rescue of mankind, to give us the continuity of our personal, social, professional lives, and even to the business, industry, nations, and even help us develop the vaccines at the warp speed, which has never been done in this thing. But then also, if you remember, first few months of the global lockdowns, we also witnessed how sustainability came to the front, how our gray skies in megapolis like Delhi started turning blue. We started hearing chirping of the birds in our concrete jungles, and the ozone layer started filling. And there's so many examples I can give about. So that's where we need to keep these two things in a balanced manner. How do we don't go berserk on either way. We don't become over-evangelizing of technology or digitalization or even sustainability. But before going into that, let's take current imperatives of the society, because we need to keep all these things in mind, because they are all going to have profound impact on our future per se. Climate change, we are talking. Energy security, what we saw in Europe, current challenges because of geopolitical issues, the cost of energy in Europe and UK has gone higher than the rents of the houses and the flats. Clean and green energy. Even today, coal, gas and oil meet 3/4 of global heat demand, making it heavily fossil fuel dependent. Energy efficiency. We normally talk about it as a added this thing, but it is actually rightly considered as fifth fuel and source of clean energy, rather than a strategy for improving our carbon footprint or whatever you like to talk about. Electricity access is still an issue in major parts of the world, you can say developing world also, but even in 2030 we are still going to have sub-Saharan areas which will still be not have access to the electricity. Global digital population, we already have 5 billion plus users on the digital thing and 4.65 billion on social media. Now it has different implications. Digital transformation. Normally we talk about digital transformation as IT and OT integration, but today network technologies, IoT and AI also have become very equally important, and all that is having a very different way of looking at things. Okay, growing carbon footprint of digital infrastructure, that we are putting digital infrastructure for everything, but without looking at the growing carbon footprint. A meaningful, safe digital life, a fair, more livable digital future for our fast evolving and technology-driven world is a very important imperative. Industry 4.0, we heard in the morning someone talk about Industry 4.0. I think we are already moving on from Industry 4.0 to Industry 5.0, where perspectives have shifted from hardcore automation to man-machine collaboration on the shop floor and sustainability at the forefront. Then sustainability and resilience, irrespective of whatever kind of society you want to build up, they are at the core of this thing. And then greenwashing. That is another issue. We see those claims that I was talking about. How do we address, handle these greenwashing, all these false claims about our imperatives, our goals, our objectives? And technology, you know, it's everywhere. It's impacting us a lot, but I'll not go. Let's look at digital transformation quickly. What it is all about? It is about improvement on infrastructure to make it sustainable and resilient. Addition of digital layer, what is the essence of the smart paradigm? And then business process transformation necessary to capitalize on the investment of the smart technology. The genesis of every digital transformation for business, organization, industry is these three. Sustainability, the true destination. Resilience, the core characteristics. And smart, merely the accelerator. And standards are the chromosomes of the digital infrastructure. And as I mentioned, it is not about only those information technology, OT. We are talking about network technology, IoT, and the new whiz kid on the block that we have been hearing since yesterday, AI. So what is digital transformation? Is it a technology? No. It is not a technology. It's a complex paradigm with domain-specific implications because we are living in an ephemeral world today. And these are some of those disruptive technologies that we are on the radar whenever we talk about all these discussions, whether 5G, 6G. It's not only single technology that plays a role. It's a culmination of different evolving technologies which get together to some inflection point to give rise to new paradigms. Like AI has been there for the last 4 or 5 decades. But in last decade only it became really very, very, this thing because high computing power, a lot of algorithm evolution, and our digital infrastructure evolution, they enabled. So how do we deal with these? And coming to our own focus area, 1G to 6G, I think today the focus of 5G and 6G is remote control and tactile internet, which Alka also mentioned just now. And this would be about the traffic dominated by correlation data. 5G, I think, and rightly somebody said, I think yesterday Satish was very skeptic about 5G. And I will say 5G is only the beginning. It's like the old, Carl-Benz automobile, the initial one which you saw. And what we are looking for is the car on the right. Am I right? And so 5G is just a foundation, a multi-industry scorecard, a generation of many firsts, but much more remains to be completed. All these aspects have been achieved somehow, but 6G is much beyond. And we are looking at a lot of aspects. I'm not stopping on these. Some of them you are already familiar. Some you can go through it later on. So what we are trying to do through the 6G, towards universal autonomy, virtualization, complete, embed, and bridge all these aspects. This thing. And then we talk about Web 3.0. It's all about blockchain, distributed cloud, and distributed web. We talk about metaverse. Now, metaverse, I'll just like to deep dive because it has an impact, and it has our 5G, 6G are big enablers of metaverse paradigm. Without 5G, 6G, your metaverse would be simply a dream, not a reality. So this is some of the elements, a quick snapshot of the metaverse, value chain, mega trends shaping the metaverse, and you see what it is all about. It's a confluence of diverse technologies, AI, all this 5G, 6G, IoT, and different AR, VR, XR, all these paradigms have got together to give rise to this new paradigm called metaverse. And these are some of the architectural aspects, some technical stack, where you see all these technologies that we have been talking about are part of it. Standardization, 3GPP has already started doing a lot of standardization work, and by release 19, I think they've got a special work group on metaverse specific this thing, and you can look up that on the Google. I don't need to get into all that. But talking about this thing, metaverse, sustainability at the metaverse computing infrastructure is resource intensive. This applies to multiple elements, from the state-of-art VR, which may create about 2,000 pounds of carbon emission over 5 years, to massive amount of compute power and energy required to process blockchain transaction. Okay, or as the, even UN has noted that these are the kind of things we need to look at and have some kind of a thing. Let's take a quick look on the future architectures. 5G, the typical, we are looking at one network, diverse use cases through network slicing and all that, and expanded capacity, everything, bandwidth. These are some of the digital infrastructure, and some glimpse into this. I'll not stop at them, you can go through later on. Harmonized communication and sensing, I think we heard it yesterday and today also. Low latency is the goal for different use cases, different level of low latency we are looking at. Toward autonomous networks and AI everywhere. Okay, 3-layer AI network architecture from manual to the O&M and hyper-automation. And then security and trustworthiness. Here, all these aspects, whatever we are talking, everywhere we have a lot of compute, lot of processing, lot of algorithms and your learnings and all these AI, whatever you like to call that. Now, what are when we talk about all these things, why do we talk about ethical implications? These all disruptive technologies have major ethical implications because whenever we do all these, apply these, there are multiple aspects of this thing which we need to look at in a very, very holistic angle. So let me give you a very interesting. Can you make out what this is? This is our Earth burning through data overload. And just to give you an example, half a century after plastic became pervasive, you know where we stand? This is a scenario. This is a very good depiction of where we stand today in context. So out of 9 billion ton plastic waste every year, we are only able to dispose of 2 billion tons safely. The rest 7 billion tons in adding within our own planet, floating somewhere or the other, or going to marine world or wherever, and getting into, as a microplastic, getting into our earth and coming back into our foods and everything, impacting everything. So what we are looking at today, and there is a lot of discussion going on in the global forums on ethical imperatives of the disruptive technologies, and one of the major contestant or the winner is AI. And what we are asking is AI the new plastic? So there are a lot of discussions going on already on the global platform, and I can go on to why it is. I think I can take this offline. But we need to learn from past mistakes. History always repeats itself. We saw how different early decisions can change these mistakes that we did earlier with a lot of these aspects. And talking about sustainable development is very holistic paradigm. It's not only about sustainability or it's not only about environment and all that. It's all about a lot of other aspects, as I think yesterday there was some discussion. But sustainability as an embedded ethical value is the real crux which nobody is looking at when we talk about this. AI is a tool for increasing sustainability, but it has innate cost to that can be just subtracted from its saving. Sustainability isn't simply a technical concern, it's an ethical concern also. We need to orient sustainability forward towards protection of people rather than this thing. But unfortunately, who is even concerned about sustainable AI? And there's a list of 14 ethical challenges for AI which have been already recognized, and you'll see sustainability as at the lowest level. People do talk about bias and explainability and all those, but nobody is willing to talk about sustainability as this thing. So there have been a lot of paper research work going on, and all these on measurement of AI carbon footprint. There have been a lot of this thing, and you already must have must know about Gebru's this thing paper in Google. Google rejected the stochastic parrots finding. Okay, and then rose into a lot of controversy. So the discussion on green AI versus red AI, what it is all about? It's about efficiency versus accuracy. There's a lot of industry pushback on factual claims. Okay, but then why do we even ask this question? Because AI has all this, the kind of carbon footprint, particularly in the NLP, and we have seen the ChatGPT and some other ethical aspect beyond sustainability already being raised, but nobody talking about sustainability per se. Standards, when we talk about for all these, there are no common standard for evaluating the environmental cost of AI system, but a diverse range of methods have been issued. Environmental costs create distribution of harms and benefits that have ethical implications. How these costs and measures can render some harms invisible or create misleading sense of scale from others, that's where measurement itself has an ethical dimension. We need a very structured granular. These are some of those, carbon footprint benchmark. There are a lot of work done already. And this is, you see how the, the carbon footprint and the capability is changing, increasing. So the question is AI for sustainability or sustainable AI? Is it not a dichotomy? So we look at this, we are actually riding the AI tiger. Can we really rein it? Or we'll be able to ride this thing? There's a whole lot of difference. And that's where we need to work a lot. But the point is, nobody's worried. This is one point I'd like to stop at. Inexact computing. In 2011, in Rice University, there was some very interesting research. It was in a different context of supercomputing. But what they said, that now that we have supercompute powers, what we do, we try to go to over-exaction, decimal to, so 10 digit, 20 digit, 30 digit beyond the decimal. Do we need that kind of exactness in every use case? We not. If you are willing to compromise a little bit of exactness and go a little inexact, we can save a lot of energy and processing power. So I think that is where optimization techniques of all our algorithms, our training models, and all these aspects need to be looked in with a fresh view, and which can help us, come up that. This is all about ecocentric approach to sustainability. I'll not stop at that, but just stop at this one slide, that when we talk about sustainability and sustainable development goal, right now we are in this area of our, the regenerative cultures. SDGs are only a bridge, they are not the ultimate goal. We need to reach, after crossing through this chasm of SDGs, we need to go to the regenerative cultures if we really want to see the future of our planet healthy, safe, and vibrant for our children. And these are different aspects of circularity and sustainability. Then coming to 5G and the environment, 5G being truly high performance communication technologies, it has already drawn this thing, and the radiation impact already has been talked, but nobody is talking about the carbon footprint, the compute that is adding day by day and day out. Blockchain, Bitcoin, this thing, but no, still we are very gung-ho in, I'm just trying to bring to the close. But green ICT, and then now here is a lot of greenwashing. Everybody says green ICT, everybody talks about clean, but how clean is the my clean energy? The solar panel, they have their own very interesting carbon footprint, nobody talks about that. Okay, how net zero is truly zero. So these are a lot of common greenwashing issues. So these are some of the things that need to be measured when we use all these disruptive technology, deploy these: run cost, production cost, expansion cost, and financial cost, electric consumption, net operation, net heat production. And then this is not only standards imperative, it's also a policy. We need to look at the local magnitude, impersonal interest, and identity. We need to identify the stakeholders for all these. So there are a lot of imperatives. I think you must have already got the hint. But we already, in a global body we call Oceanics, we have written a think piece, is AI the new plastic? There's a link for that. You can look, Google it, and you'll find this document where there's the whole narrative about all this aspect. But then, what is the impact of future networks of sustainability? Sustainability has been established as a cornerstone of 6G we all talk about. But as investigations on 6G architecture are explored in various communities, energy and broader sustainability challenges have been identified. The use of virtualized platform for radio access network processing imply greater energy use and more cloud platforms to be managed. Introduction of AI ML everywhere in 6G suggests energy-hungry computations and specialized power-hungry process. What are the power sources for all these cloud platforms that we are going to use? Especially on a global basis with computing so widely distributed, not solely in giant or well-managed data centers now. There's a lot of, when you say elastic cloud, we will have that hybrid clouds. You are moving data from one cloud to another. That's again a lot of carbon footprint, energy, this thing. There's a lot of issue, long-term goal of 6G. So trying to close it down, so the imperatives are we need to look at all these aspects. Climate change, sustainability are a wicked problem. Dealing with them means we find solution at the intersection of social, technological, and economic and natural systems. But when we solve one problem using technology, we must not create new problems. This is why we are sustainable in doing everything, both environmentally, economically, and socially. So these are some of the points that are important for 6G or the digital infrastructure: network efficiency, small cell migration, base station power, economic factors, and grid and utility. How we use grid, what kind of grid infrastructure we leverage, that also will have that. So when we look at sustainability, we need to use the whole is greater than sum of the parts. I think that's a philosopher which said, but we use this in engineering today, system engineering, as a major approach that we need to apply a system engineering approach of all these. I'll not get into all this, it's all here. But basically, it is all about a holistic iterative discovery process that helps find defining the right problem to complex situation, and then in finding elegant and well-designed and working solution. It incorporates not only engineering, but also logical, human, and social aspects. So these are the system energy efficiency imperatives for our 6G or future networks. On each and every aspect, we are looking at this thing, and we need to work toward these targets.
Mr. Narang,
I'm just closing, so I think these are some of the thoughts and perspectives, summary of all this, but I'll try to stop at, I'll not go through all this. So the main this thing is need to develop a comprehensive approach to sustainability, security, and resilience, leveraging disruptive technology but ethically aligned design, and adopt system approach to design any complex paradigms. It is not a call for action for standards or people or only, it's for all. So SDOs, government, policymakers, regulators, system developers, and business organizations, academia and researchers, and intergovernmental and NGOs. I'll not stop at that, but one just to this thing. So the last this thing would be, we humans need to radically change our relationship, not just with the planet, but with the objects with which we fill our lives. We need to change how we think about technology and innovation. Rather than allowing technological advancements to steer our narratives, innovation and technology should help us build bridges between the world we inhabit now and the one we imagine for tomorrow. Thank you very much for the sustainable and resilient future. Thank you.
Thank you, Mr. Narang. I am very sure there's a very, very important dimension to the entire sector, especially the sustainability. Sorry, because of time constraints,
I
fully
am
cognizant. It's a really, really interesting and a very, very important paradigm that's required, that cannot be ignored when we move towards 6G. Thank you once again. And now I think let me welcome Mr. Indrajit Singh. Actually, he's the Chief Cyber Officer. As we all know, the 6G in 6G, one of the key things is about security. The challenges in security is going to be really a great concern. We know that blockchain is being taken to the core, edge, etc. That will be part of one of the secure aspect. We even talked about trust infrastructure being one of the key infrastructure that is over which 6G is being going to build. We even spoke about quantum cryptography and QSD, etc. Because security challenges are really going to be a big, big challenge in the 6G era. Let us now welcome Mr. Indrajit for his presentation. On to you, Vijay.
Thank you, Chair. Thank you, audience and dignitaries on the dais, off the dais, and thank you, Bharat Exhibition, Shashi, for having me here today. Very important topic, but I'm between your lunch and the talk which I'm going to give. So I'll try to keep it very short and sweet, not go on a very repetitive things which you already discussed, and we've been talking of 6G. I'll try and come only on the cybersecurity part of it. And always remember, the cybersecurity as an area now has become so important that while we are talking, every 11 seconds there is one ransomware attack. And the attack is done by no other than yourself, because all attacks start by one click, whether it's any technology. And the topic of this session was a metaverse. And just to give you a feel of metaverse, who are the people who are not aware of metaverse, it's a second universe, so-called. And how do you get into that? You'll have a headset, which you'll use called AR or VR, augmented reality and virtual reality. And with that, you can go buy land, buy property, buy things, go for a party, go to school, teach there, have an office, different places you got to be there. While having said so, the metaverse, your 5G becomes the most important factor, which is the underlying technology for making it a reality. And when we talk of the 6G, it's a holographic things which we are going to see. And the cybersecurity in metaverse itself has become a major challenge today. Like you have normal Facebook, Twitter, you have the data privacy which are there, cybersecurity challenges which are there. The metaverse has got a complex problem. We've already seen a rape happening in a metaverse. We are already seeing manipulation of data happening in metaverse. Your monetization of data happening in metaverse. And these technologies are going to play a major role in your life. And one of the study by Citi, that Citibank says that it's going to disrupt the technology by $13 trillion by 2030, and almost 5 billion people will be on metaverse, right? So if that be the case, the baseline technology remains 5G and coming to the 6G. So I'm not going to repeat all these things. I'll skip over these slides, But what the use cases are going to be, you're going to have connected intelligent machines, you have going to have cognitive intelligence, you have connected sustainable world, and Internet of Senses. In the morning, one of the panelists was bringing out the senses being transported. You're going to have a limitless connectivity, small cells, your trustworthy systems, cognitive networks, and network fabric. So it's going to be a combination of cyber physical system. We speak of digital twin. This is the technology which is going to be, enhancing it. Industry 5.0, where we are going to have the sensors, we are going to transport everything what we are doing, the physical world, getting into your virtual world and working on there. So modern technologies, modern industries which are going to happen, they are all going to be IIoT based. It's not going to be the devices or the components coming to the machine, the devices will self-travel based on the requirement, using the RFID, using the technology, the IIoTs, and going to the manufacturing bay. That is how the cyber-physical systems are going to be there. And what is on the anvil? You're going to have a challenge of something. We have been all talking about the IT security. There's going to be a challenge of OT security. That's operational technology. Everything is going to be operational technology. And the other challenge is, today we are worried about data. In the operational technology, we're going to be worried about the life of human beings. Because one sensor going wrong, you will have a major damage. That's not just your data. So you have to think of the paradigm which is changing, the way the technologies are changing, and you're going to face the different kind of challenges ahead. Coming on to the last part of the 2030, I'll not jump to the layers because we were not worried about the attacks of the magnitude which we are seeing. We are talking the AI, and one of the speakers before me spoke of AIs and in antennas at the base stations. Remember, if that AI data is poisoned, what's going to happen? We always talk of good part of data, but if there's a data poisoning, it's really going to create havoc. And again, somebody brought it out, we are not using 74% of data, we are just using 26% of data. If that be the case, if it's 100% usage, just imagine 6G, underlying technology, it's going to have what are the ramifications which are there. Zero-day attacks are not going to go away, right? We are going to have quantum computing. Everybody talks of quantum computing, but it's going to bring along the quantum attacks, right? In addition, we are going to have the physical layer attacks which are already there, the virtual light, the light attacks which are going to be there, already there. Now, when we talk of the AI and ML, we also talk of the blockchain. And blockchain is going to be a major technology which is going to be used in 6G. I don't know, somebody spoke of it, but it's going to be creating the frequency reuse, frequency kind of spectrum issuance. It's going to play a major role in that particular thing. And of course, the quantum computing, which is going to play a major role, right? So each of the use cases which we talk of, whether it's your holographic telepresence, your extended reality, we talk of connected autonomous cars or smart grids, or intelligent healthcare, digital twins, UAV mobility, all of them are going to have their share of threats or the cyber threats which are already on the anvil. There's going to be challenge of the privacy, there's going to be challenge of of course, interoperability challenges are there. IoT devices, which we talk of, have got a major challenge of security because they are so small sensor, we can't put encryption on it, right? And those are the kind of things which we are already seeing it, but the baseline technology, 6G itself, we have to think of security by design. Always, till date, we have been thinking of security as a requirement, as an afterthought. Now, we have to think security by design for the 6G. Then only going forward, we will be in a state where, because to safeguard those networks, because we are going to have NFVs or SDNs. Blockchain, of course, it's told to be safe, but I always say the blockchain has got an own challenge of the cyber attacks. We have seen cyber attacks happening on the blockchain networks, so that's also on the anvil. Right, I'll skip the slides, more or less. So the security challenges with the AI ML, which are going to be there, is the security visibility part of it, trustness part of it, your ethical and legal aspects, extendability and viability, controlled security tasks and adaptability of models when it comes to the security challenges when we are going to have the AI ML incorporated into the 6G networks. And attacks and threats are going to be phenomenal. This list is just the tip of the iceberg. It's the API-based attacks, your poisoning attacks, that's going to be the biggest challenge. I'm already seeing it. The data poisoning, evasion attacks, your physical layer attacks, model inversion attacks, AI middleware layer and model stealing attacks. So those are the kind of attacks and threats which are already there. And while we were talking of the antenna design, your network design, your, kind of a surface area which your nodes are going to cover, they're equally going to have a problem of authentication, your key management, because 6G is going to bring in the problem of the cryptographic key management. Your quantum computing considerations are going to be a bigger challenge to manage, because you're going to have so many number of cells which you're going to create. How are you going to have that quantum computing? Your optimization of your networks, right? Again, because one optimization is not done, it's going to be a problem. Your short-lived networks, your asymmetric cryptographic keys, your cloudification, because everything is getting into cloud, right? Your visibility and configurability, and your interconnect security. So those are the kind of things which you already seeing. I'll come to this slide to end up. So if you look at it, you have the 6G at the core, and you have the platform, you have the functions, you have the orchestration, and you have the specialization of the 6G architectural innovation. And when it comes to your edge intelligence or cloudification, you're going to have the threats of data privacy, your AI/ML attacks, your security on the cloud, your security on the edge. We are talking of edge computing right now. Everybody's talking about Gaga, but then the security at the edge. And there's a new topic for discussion with everyone, data at edge, right? So how you're really going to manage the data at edge, because you don't know how to configure the data at edge rightly today. Then you have the specialized subnets, part of your intelligence radio. So again, the trust violations, your AI/ML attacks, psi-layer attacks, and then comes to your RAN core convergence. Again, you have the challenge of AI/ML. Just see, in each of the functions, whether it's a physical functions or your orchestration or specialization, each of the layers, you have the problem of AI/ML attack, come what may. And complementing it is the APIs, your data privacy, your user privacy, your psi-layer attacks, those are not going away. So that's a kind of challenges which are on the anvil when it comes to the 6G security concern. And while all the people who are the R&D, they need to really get onto the drawing boards, incorporate these kind of threats which are already visualized by the researchers. There's lots of research which is happening, and I'm very sure we'll have the best of the security when we move ahead to the 6G. So with this, I've come to the end. Thank you very much. It's a really pleasure to be with you all. Thank you.
Thank you, Indrajit. That was very interesting, and I think there's a long way we need to go for the cyber security, especially in the front with the 6G and the new networks coming in. And because of paucity of time, I think we are not going to take any questions during the lunch session. Probably we can touch base with the speakers if you have any questions available.
So we'll have the lunch, during the lunch we'll have the question answer. Sorry for that. May I request the chairman to present the mementos to the distinguished speakers. First to Alka. Then to Colonel Inderjeet Singh. Narayan Kishore. Chairman has already received the memento, so every session we don't have to give it. So ladies and gentlemen, we'll have a quick lunch break and then we'll come back. The speakers' lunch are on the other hall, only for the speakers. They have to go to that, the next hall. Rest of the lunch is here. Thank you.